Okay, suppose we have a function of y equals 2 to the x power. This x here is called hopefully you already know what x is. X is called an exponent. And this 2 is called the base of the exponent. Now, you probably learned that in previous sections when you were learning about the rules of exponents, like 2 to the third times 2 to the fourth is 2 to the seventh, that kind of stuff. 2 is the base, and the power is also called the exponent. Well, this function with an input of x and an output of y is called an exponential function. Exponential function. A function is an exponential function when the input is the exponent. So if we want to know what this function would look like if we graphed it, I mean, functions were kind of made to be graphed. I mean, you can graph any function by pairing up x's and y's, inputs and outputs, that make the equation of the function true. So let's create a table of values for x and y. Okay, suppose x equals, I'm going to start down here for a purpose, 1. Suppose equals 1. Y would be 2 to the first power. That will be 2 to the first will be 2. This gives us a point on the graph of the function. Input is 1, output is 2. That gives us the point 1, 2 on the graph of the function. 1, 2. How about if x equals 2, y would equal 2 to the second power of x equals 2, y would equal 2 squared, or 4. So we have the point 2, 4. If x equals 3, then y would equal 2 to the third power, or 8. Now, I don't have room on this coordinate plane to get all the way up to 3, 8, but it will be way up there. Now, suppose x equals 0. Notice the pattern here. 8, 4, 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2, oh, this should be a 1 to fit the pattern. Divide by 2, divide by 2, divide by 2. And hopefully you remember from previous experience that anything to 0 power is 1. So if x equals 0 to the 0 power, that's 1. That gives you the point 0, 1. How about if x equals negative 1? Well, I keep on dividing by 2, divide by 2, divide by 2. What do I get if I divide 1 by 2? 1 divided by 2? 1/2. So 2 to the negative 1 power is 1/2. If x equals negative 1, y equals 1/2. That gives us this point right here, negative 1, 1/2. And if x equals negative 2, y would equal, well, 2 to the negative 2 power. We'll follow the pattern. Just keep dividing by 2 to move up. What's half of 1/2? That's 1/4. So 2 to the negative 2, 2 to the negative 2 is 1/4. It's the reciprocal of 2 to the positive 2. So I've got the point negative 2, 1/4. And then negative 3, I keep dividing by 2, that will be 1/8. Negative 3, 1/8. It's super, super close to the x-axis. I can just put a little dot there. So I'm not even going to attempt to connect those dots, but it would be a curve that would swoop up like that. The actual function will be a curve that would be shaped through those points right there. And that's an exponential function. Now, this particular exponential function is called a growth function because as x gets bigger, the output grows. As the input uh, increases, the output grows. Now, we could also make this a little bit fancier. We could take this and suppose we wanted to start with, say, 3 times 2 to the x. 3 times 2 to the x. Well, let me grab a coordinate plane. I'm going to use this one this time. All right, well, if x equals 0, let's make another another table of values. 3 times 2 to the x. If x equals 1, then 3 times 2 to the first power. 3 times 2 to the first. Is that 6 to the first power? Or is it 3 times 2 to the first power? Well, in this particular instance, it's not going to matter which way, but order of operations would tell us that we have to raise 2 to the first power before we multiply by 3. That's going to be 6. So what point does that give us on this function? It gives us the point 1, 6. 1, 6. What if x equals 2? We'd have 3 times 2 squared. Now here's the real question. Is this 6 squared or is it 3 times 4? Do we do this? Do we square the 2 and then multiply by 3, or do we multiply and then square? The answer is order of operations as to the exponent first. So 2 squared is 4. 4 times 3 is 12. So 2 is the x coordinate, 12 is the y coordinate. That will be way up there above where I have my coordinate above 10. Now, what about 0? We'd have 3 times 2 to the 0 power. What's 2 to the 0 power? It's 2. It's 1. Sorry. Anything to the 0 power is 1. 3 times 1 is 3. So that would give us the point 0, 3. Negative 1. 3 times 2 to the negative 1. 2 to the negative 1, that's 3 times 2 to the negative 1 is 1/2. So that will be 3/2 or 1.5. Notice, every time we're dividing by 2 each time. So negative 1, 1.5. Negative 2, we're going to keep dividing by 2. 3 times 2 to the negative 2, that's 3 times a fourth. That's going to be 3/4. So negative 2, 3/4. Negative 3, 3 times 2 to the negative 3. 2 to the negative 3 is 1/8. 3 times 1/8 is 3/8. So a little bit less than half. So, and as we keep on getting closer to the x-axis, notice it won't ever equal 0. No power of 2 equals 0 ever. It's going to get closer and closer to the x-axis, but never ever touch it. Same with this function here. It just gets closer to the closer and closer to the x-axis. Now, if we made this 3 a negative 3, all that would happen would be, let's see, if we change this to and make it negative 3 times 2 to the x, we could create another table of values, but all that's going to happen is all of these outputs, we're going to be multiplying by negative 3 instead of positive 3 each time. So what's going to happen is, let's see if I can make this happen. It would just do this. you'd have negative outputs instead of positive outputs. That's the only effect that that would have, because you'd be find those powers of 2 and then multiply by -3 instead, which would cause your outputs to be negative. That's pretty much an introduction to how exponential functions work. And if the base is greater than 1, then you're going to be growing, and that's what this, and if the base is less than 1, you can end up getting smaller. If you multiply a fraction by itself, you actually get smaller. But if the base is greater than 1, you multiply a number greater than 1 by itself over and over, you get bigger and bigger and bigger. And so the base can be anything greater than 1, and you'll end up growing just like this, and it grows really, really fast.